Righty, ladies and gents, in this video we're going to go over how do we evaluate definite integrals with substitution. So in the previous video we went over how to do definite integrals. Now this video is similar thing, we're going to do definite integrals, but this time we have to do substitution before we can evaluate the integral. So I'm going to do just one quick example here. So for example, suppose we had the integral from 0 to 1 of x times x squared plus 4 to the 4th power dx. All right. So it turns out there's actually two different ways that you can solve these integrals. I'm going to show you one way, and then I'll briefly mention the other way. But what we're going to do is, first of all, let's just do our normal substitution, as we've covered in previous videos. We're going to let u equal x squared plus 4. And then that means that du is a 2x dx. Well, the differential of my integral is a 1x dx. So if you guys remember, the trick is that I take the coefficient of understood 1 here, divided by 2. So 1/2 is the constant multiple that I need to apply to both sides of my du equation. So 1/2 times a 2x gives us a 1x dx. All right, let's go ahead and perform the substitution. And so we're going to have our integral sign. And here is the deal. The way that I'm going to show you how to solve this is I call it the lazy way. Basically, what this means is that we are going to keep our bounds, our limits of integration, the 0 and the 1, we're going to keep them in terms of x. So what that means is that when we're about to switch over to u, the u variable. And so what that means is that I'm going to drop my bounds for right now. I'll explain more in a second. So ignore the bounds for right now. And then x squared plus 4 becomes u to the 4th. And then the 1x dx becomes a 1/2 du. All right, let's keep it moving. So now we can actually integrate. And so this becomes 1/2 times u to the 5th over 5. Remember, technically there's a plus c, but remember the plus c's are going to cancel each other out once we start to plug in the bounds. So don't worry about that yet. All right, just cleaning this up, we get multiplying these fractions, multiplying the numerators, we get u to the 5th over 2 times 5, which is 10. Okay. Okay, and then we have to replace u with its expression in terms of x, and we said that u is x squared plus 4. So this becomes x squared plus 4 to the 5th over 10. And now we're going to bring back our bounds, because now we're back in terms of x values. Okay, we didn't have them before because we were working with the u variable, but now since we're back in terms of x, we can bring in our x values. All right, and then from here is just the fundamental theorem of calculus, which we've covered before in previous videos. So we're going to plug in 1 first for x. So it's going to be 1 squared plus 4 to the 5th power over 10 minus, 0 squared plus 4 to the 5th power over 10. Okay, 1 squared is 1, 1 plus 4 is 5. So we're going to get 5 to the 5th power over 10 minus, 0 squared, 0 plus 4. So we're going to have 4 to the 5th power over 10. Okay, so let's see, 5 to the 5th. I think I have that in my calculator. No? Yeah. All right, 5 to the 5th power, I believe, is 3125. Okay, and then 4 to the 5th, while we're at it, that is 1024. Okay, so we have 3125 over 10 minus 1024 over 10. All right. And so now, since we have the same denominator, we can simply subtract those numerators. So 3125 minus 1024 leaves us with, I'm just being lazy, 2101 over 10. And that's as far as we can reduce that. So that is our definite integral that we solved using substitution. Okay, so what I quickly want to do, as I mentioned earlier, is that there are two different ways you can really go about solving these definite integrals when you have to use substitution. So the way that I just showed you now is a bit of a longer way, but it involves you not having to worry about changing your limits of integration, your upper and lower bounds, what I'm referring to. Let me show you a slightly quicker way. It's optional. You don't have to do it this way. If you like the first way, feel free to cut off the video here. But it's another way of solving that exact same integral is this. Instead of switching everything back in terms of x, I can now rewrite my bounds in terms of u. So what do I mean by that? So really quickly, let's redo the problem. So it was from 0 to 1. It was, what was it? X times x squared plus 4 to the 4th. dx. Okay, all right. Once again, we've already done the u substitution. U is x squared plus 4. Du is a 2x dx, but I have to multiply that 2x dx by 1/2 to get my differentials to match up. Okay, so here we go. Here is the different part. So now what we can do is, remember our initial bounds are in terms of x. So this, go to the original integral. This is x equals 0. This is x equals 1. What we could do, if we don't want to go back to the x variable, what we could do is we can actually transform those x values to u values. Well, how do we do that? Well, we know that u is x squared plus 4. So when x is equal to 1, that means that u, plug that x value into your u equation. That means that u is a 1 squared plus 4, which ends up being a 5. Okay? So if we're working strictly with u's, that means that the upper bound in terms of u is a 5. What about when x is 0? That's our lower bound. When x is 0, take that x value of 0 and plug it into the u equation. So then u would be 0 squared plus 4, which equals 4. So in terms of u, our bounds actually go from 4 to 5. And then perform the substitution as we did in the equation, the integral before. It just becomes a 1/2 u to the 4th power du, just like we did before. And now, once we integrate, we're going to get a u to the 5 over 10, just like we did before. But now the cool part is that instead of going back and switching this back into terms of x, I can now stop right here and I can now say, oh, I need to evaluate this from u equals 4 to u equals 5. Okay, because those are my bounds in terms of u. And you're going to see we're going to get the exact same answer, because this will be 5 to the 5th power over 10 minus 4 to the 5th power over 10. And if you notice, I'll stop it here. If you notice, that's exactly what we got right here. Okay? So the second way that I showed you involved changing our bounds of integration. Not necessary, like I said, you could just do it the old way if you want to, but that way is a little quicker. And so some people do prefer that method. All right, hopefully that clears up how to do definite integrals with substitution. I'll see you guys in the next video.